the use of it is to compare two sample means where each sample is less than 30 and standard deviation is given. Okay, so before going into the formulas, we will see two comparison of terms. First is paired t-test versus unpaired t-test. So in this video we will gonna look at unpaired t-test, but for differences between two. So paired t-test, there is one group which is given one intervention like this. So there are two observations made. One is before intervention, that is A, and one is after intervention, that is B. And both of these observations are compared later on and the t-test is applied. That is called paired t-test because two observations are paired together for one sample. Unpaired t-test is when two samples are not paired, aka they are independent. So there are two groups and there are two individual observations. So one group undergoes intervention by drug A, let's say, and observation of A is made, and drug B undergoes treatment and drug B is given to sample 2, which gives us observation of B, and both of these observations are later compared with t-test, which is called unpaired or independent t-test. Another term that you should know is one-tiered t-test versus two-tiered t-test. So let's say there are two mean given, one is 35 and second is 30. So alternate hypothesis can be of two types. We have discussed this before, but the actual term are gonna be discussed here. So if the question says find out whether there is significant difference between two mean, so significant difference, this is the key term, that will be called as two-tiered t-test. Why? Because we have two possibilities as in here, it can be either less than, significantly less, or significantly high. So probability of it being out of 95% confidence interval can be divided into 2.5% of being it less than significant and 2.5% being more significant. One-tailed t-test or one-tailed hypothesis, which is one mean is more or less, not both, than other. So here mu1 is more than mu2, which is significantly more. It is a mistake, significantly more. So graph will look like this. There is only one possibility that it can be higher. Above this level it will be significantly higher, below this level it will be within non-significant range, and entire probability is 5%. Here it was divided between 2.5 2.5. Now we will go to formulas. So in this part we will only discuss unpaired or independent t-test. So formulas, we can have multiple situations. So like first situation is when sample mean is to be compared with population mean. So this is just like a z-test, but let's say the sample was less than 30, so you will rather use t-test than z-test. Z-test can also be used, but we will prefer to use t-test in sample that is less than 30. The formula is, now if you see, this part is just like z-test. Root n is the sample size, is added, and in standard deviation formula there is n minus 1 because the sample size is very low, which is less than 30. So this is the first formula. For situation 2, this is very important situation because this is most commonly used. Now difference between two means, these are two sample means usually, so the formula can be this or this. Now this is a little bit complicated formula where sample pooled standard deviation is used. Now the answer that you will get after using both of this formula will not be that much different. So you can go with this easier formula as well as you can go with this formula if you have to find precise answer. We will mostly use this formula for example. Now other formula like degree of freedom, now this is, as you can imagine, is derived from normal degree of freedom is n minus 1, right? So this, now because we have two samples, so n1 minus 1 and n2 minus 1 together, this will be like this. Okay, now problem. We have two problems in this lecture. So a manufacturer of a drug notices following plasma concentrations in test subjects for a drug X: 19, 21, 25, 16, 17, 14, 21. Now we have to find out whether these values are different from the same drug available in the market by another brand that is having mean plasma concentration of 20. Now we are not given standard deviations because we have to find it out from this. Okay, so we will first calculate. First step will be always hypothesis, and as you know, null hypothesis is that both mean are same, alternate is that they are different. Calculation of t. Now first we will have to find out the mean of these 7 values, which will be 19. You can pause it here and calculate it yourself. Now this will be 0, this will be minus 2, this will be minus 6 plus 3 plus 2 plus 5 minus 2. We will square it. This is 9, this is 4, 25 and 4. The total of it will be called as sigma of x minus x bar square, which is 82, and we will put this in this formula of standard deviation. 82, and total we had 7 observations, so 7 minus 1, it will be around 82 upon 6 and root, which is around 3.7. Now we'll put these values in here. The question said that population plasma concentration, we'll take this as population plasma concentration, is 20. So 20, the mean here is 19. The standard deviation was 3.7. This will give us value of around negative 0.72. Now t tabloid was given as 3.707. So this value comes out to be less than tabloid value, which means it is non-significant. Now this was as we saw here, it was a two-tailed test because we had both the possibilities. It can be lesser or it can be higher than the population mean. But let's say the question was asked, is the sample mean significantly lower than population mean, which means if alternate hypothesis was this, then all the steps till step 3 would be similar, but in step 3 you will have a different tabloid value, and how to calculate that different tabloid value will be discussed in another video. Step 4 is conclusion. Now because the value was non-significant, H0 has to be accepted, and there is no significant difference between two means. Okay, on this we can say if this was 95%, then the value of negative it will be around here, negative 0.72, and it is non-significant. Okay, so next is another problem. Now this is a very important problem because it is the most common use of t-test. This type of situation is the most commonly used t-test. Now a drug reduces blood glucose by 70 on average, standard deviation of 50 among 40 study participants. So we have first situation where 70 reduction, N1 is 40 participant and standard deviation is 50. Now another drug has mean of 74, standard deviation 25 and 20 participants. So we have to find at alpha of 0.05. Now alpha of 0.05 is equal to significance level of 95% or significance level of 5% and confidence level of 95%. So all these are synonyms. Now at 0, the first mean and second mean will be equal, and alternate they won't be equal. Test statistic, we just saw this formula. There is another formula which is a bit difficult, and it will also give kind of similar value. So we will use the easier one. I would advise to use this formula only because it is very easy and there are less chances to be for mistakes to be made. So x1 minus x2 is 70 minus 74 root s1 square, which is 225, s2 square, which is 625, and there will be n1 which is 40, n2 which is 20. It will be negative 4 upon, we'll calculate this one. So this value right here is 5.625 plus 31.25, which will be around negative 0.66. Now this calculated value is less than tabloid value, as you can see, so it is not significant. So conclusion is H0 is accepted, and you can also draw a table. The value will be somewhere around here, 0.66. This is mean. Okay. So this way you can calculate the t-test, and significance of differences between two means can be calculated. Now for the problem, practice problem, you have this data and you have to use t tabloid as 2.15 only. Okay, so calculate this, answers will be in description.